of rational numbers. Method. Step 1. For adding two or more rational numbers, we should first of all rewrite them with positive denominator. Step 2. Check whether the denominators are same or different. Case 1. When given rational numbers have same denominator, let us take the rational number a by b and c by b. They have same denominator. So we define the sum of a by b and c by b as a by b plus c by b is equal to a plus c by b. Example 1. Find the sum of a 1 by 2 and 3 by 2, b 2 by 4 and minus 3 by 4. Solution. A. Rational numbers 1 by 2 and 3 by 2 have positive and same denominators. So, 1 by 2 plus 3 by 2 is equal to 1 plus 3 by 2, which is equal to 4 by 2, which is equal to 2. B. Again, rational numbers 2 by 4 and minus 3 by 4 have positive and same denominators. So, 2 by 4 plus minus 3 by 4 is equal to 2 plus minus 3 by 4, which is equal to 2 minus 3 by 4, which is equal to minus 1 by 4. Case 2. When denominators of given numbers are unequal. Method. In this case, we take the LCM of the denominators and express each rational number with LCM as the denominators and then add as above. Example 2. Find the sum of 1 by 2 and 5 by minus 6. Solution. LCM of 2 and 6 is 6. Therefore, 1 by 2 plus minus 5 by 6 is equal to 1 multiplied by 3 plus minus 5 multiplied by 1 by 6, which is equal to 3 minus 5 by 6, which is equal to minus 2 by 6, which is equal to minus 1 by 3. Properties of addition of rational numbers. Properties of addition of rational numbers are similar to the properties of addition of integers. 1. Closure property. The sum of any two rational numbers is always a rational number. That is, if a by b and c by d are two rational numbers, then a by b plus c by d is also a rational number. 2. Commutative property. Two rational numbers can be added in any order. Their sum remains same. Thus, if a by b and c by d are any two rational numbers, then a by b plus c by d is equal to c by d plus a by b. 3. Associative property. The sum of three or more rational numbers does not depend on the order in which they are grouped. That is, order is immaterial. Thus, if a by b, c by d and e by f be any three rational numbers, then in the bracket a by b plus c by d plus e by f is equal to a by b plus in the bracket c by d plus e by f. 4. Existence of additive identity or property of 0. Sum of any rational number and 0 is the rational number itself. Thus, if a by b is any rational number, then a by b plus 0 is equal to a by b, which is equal to 0 plus a by b. The rational number 0 is called the identity element for addition of rational numbers. 5. Existence of additive inverse or negative of a rational number. For every rational number a by b, there exists a rational number minus a by b, such that a by b plus minus a by b is equal to 0, which is equal to minus a by b plus a by b. minus a by b is called the additive inverse of a by b, and a by b is called the additive inverse of minus a by b. Example 1. Verify that minus of minus x is equal to x for x is equal to minus 13 by 17. Solution. Given x is equal to minus 13 by 17. So, minus x is equal to minus 13 by 17, which is equal to 13 by 17. And minus x is equal to minus 13 by 17 is equal to minus 13 by 17, which is equal to x. Hence verified. 6. Property of 0. If 0 is added to any rational number a by b, then sum is the same rational number a by b. That is, a by b plus 0 is equal to 0 plus a by b, which is equal to a by b. Example. 2 by 3 plus 0 is equal to 0 plus 2 by 3, which is equal to 2 by 3. Subtraction of rational numbers. For rational numbers a by b and c by d, we define a by b minus c by d is equal to a by b plus minus c by d, which is equal to a by b plus additive inverse of c by d. Properties of subtraction. Properties of subtraction of rational numbers are similar to the properties of subtraction of integers. 1. Closure property. The difference of two rational number is also a rational number. If a by b and c by d are any two rational numbers, then a by b minus c by d is also a rational number. 2. Commutative and associative properties. Subtraction of rational numbers is neither commutative nor associative. 3. Property of 0. If 0 is subtracted from any rational number a by b, then difference is the same rational number. That is, a by b minus 0 is equal to a by b. Example 1. The sum of two rational number is minus 2. If one of the number is minus 14 by 5, find the other. Solution. Let the other number be x. Then x plus minus 14 by 5 is equal to minus 2. X minus 14 by 5 is equal to minus 2. X is equal to plus 14 by 5 minus 2. X is equal to 14 minus 2 multiplied by 5 by 5. X is equal to 14 minus 10 by 5, which is equal to plus 4 by 5. Hence, the required number is 4 by 5. Example 2. What should be added to 2 by 3 so as to get 1 by 15? Solution. Let us suppose that the required number to be added be x. Then, 2 by 3 plus x is equal to 1 by 15. X is equal to 1 by 15 minus 2 by 3. X is equal to 1 minus 2 multiplied by 5 by 15, which is equal to 1 minus 10 by 15, which is equal to minus 9 by 15. X is equal to minus 3 by 5, reducing to lowest terms. Hence, the required number is minus 3 by 5. Multiplication of rational numbers. If a by b and c by d are any two rational numbers, then their product a by b multiplied by c by d is defined as a multiplied by c by b multiplied by d. Example, find the following products. A. 2 and minus 3 by 5. B. 3 by 11 and minus 5 by 7. Solution. We have A. 2 multiplied by minus 3 by 5, which is equal to 2 by 1, multiplied by minus 3 by 5, which is equal to 2 multiplied by minus 3 by 1 multiplied by 5, which is equal to minus 6 by 5. B. 3 by 11 multiplied by minus 5 by 7, which is equal to 3 multiplied by minus 5 by 11 multiplied by 7, which is equal to minus 15 by 77. Properties of multiplication of rational numbers. Properties of multiplication of rational numbers are similar to the properties of multiplication of integers. Property 1. Closure property. The product of two rational numbers is always a rational number. If a by b and c by d be any two rational numbers, then a by b multiplied by c by d is also a rational number. Property 2. Commutative property. The two rational numbers can be multiplied in any order. Their product remains same. Property 3. Associative property. Product of three or more rational numbers does not depend on the manner in which they are grouped. Consider three rational numbers a by b, c by d and e by f. Then in the bracket a by b multiplied by c by d multiplied by e by f is equal to a by b multiplied by in the bracket c by d multiplied by e by f. Property 4. Existence of multiplicative identity or property of 1. The product of any rational number a by b and 1 is the rational number itself. That is, a by b multiplied by 1 is equal to a multiplied by 1 by b, which is equal to a by b, which is equal to 1 multiplied by a by b. 1 is called the multiplicative identity or identity element for multiplication of rational numbers. Property 5. Property of 0. Every rational number when multiplied by 0 gives the product 0. If a by b is a rational number multiplied by 0, then a by b multiplied by 0 is equal to 0 multiplied by a by b, which is equal to 0. Property 6. Existence of multiplicative inverse. For every non-zero rational number a by b, there exists a rational number b by a, such that a by b multiplied by b by a is equal to b by a multiplied by a by b, which is equal to 1. The rational number b by a is called the multiplicative inverse or the reciprocal of a by b, and a by b is called the multiplicative inverse or the reciprocal of b by a. Remember, a, 0 has no reciprocal. B, reciprocal of 1 is 1 and reciprocal of minus 1 is minus 1. Example, A. Reciprocal of 3 by 5 is 5 by 3, as 3 by 5 multiplied by 5 by 3 is equal to 3 multiplied by 5 multiplied by 3, which is equal to 1. B. Reciprocal of minus 7 by 9 is 9 by minus 7, as minus 7 by 9 multiplied by minus 9 by 7 is equal to minus 7 multiplied by minus 9 by 9 multiplied by 7, which is equal to 1. Property 7. Distributive property of multiplication over addition. For any three rational numbers a by b, c by d and e by f, we have a by b multiplied by in the bracket c by d plus e by f is equal to a by b multiplied by c by d plus a by b multiplied by e by f. Example 1. Find the reciprocals of each of the following. A. 3 by 4. B. Minus 7 by 5. C. Minus 9. D. 1 by x when x is not equal to 0. Solution. A. Reciprocal of 3 by 4 is 4 by 3. B. Reciprocal of minus 7 by 5 is 5 by minus 7, which is equal to minus 5 by 7. C. Reciprocal of minus 9 is 1 by minus 9, which is equal to minus 1 by 9. D. Reciprocal of 1 by x is x. Example 2. Verify that minus 2 by 7 into in the brackets minus 3 by 7 into in the bracket minus 9 by 14 is equal to in the brackets minus 2 by 7 into minus 3 by 7 into in the brackets minus 9 by 14. Solution. Minus 2 by 7 into in the brackets minus 3 by 7 into in the brackets minus 9 by 14 is equal to minus 2 by 7 into in the brackets minus 3 into in the brackets minus 9 by 7 into 14, which is equal to minus 2 by 7 into 27 by 98, which is equal to minus 54 by 686, which is equal to minus 27 by 343, and in the brackets minus 2 by 7 into in the brackets minus 3 by 7 into in the brackets minus 9 by 14, which is equal to in the brackets 6 by 49 into minus 9 by 14, which is equal to minus 54 by 686, which is equal to minus 27 by 343. Hence verified that minus 2 by 7 into in the brackets minus 3 by 7 into minus 9 by 14 is equal to in the brackets minus 2 by 7 into minus 3 by 7 into in the brackets minus 9 by 14. Division of rational numbers. If a by b and c by d are two rational numbers such that c by d is not equal to 0, then a by b divided by c by d is defined as a by b divided by c by d, which implies a by b multiplied by d by c, which is equal to ad by bc, where a by b is called the dividend, c by d is called the divisor, and the result is known as quotient. Note, thus for division of two rational numbers, we multiply dividend by the reciprocal of the divisor. Example 1. Divide a 4 by 9 by minus 5 by 12, b minus 3 by 4 by minus 5 by 9. Solution. A. 4 by 9 divided by minus 5 by 12 is equal to 4 by 9 multiplied by minus 12 by 5, which is equal to 4 multiplied by minus 12 by 9 multiplied by 5, which is equal to minus 48 by 45, which is equal to minus 16 by 15. B. Minus 3 by 4 divided by minus 5 by 9, which is equal to minus 3 by 4 multiplied by minus 9 by 5, which is equal to 27 by 20. Example 2. If the product of two numbers is minus 5 by 8 and one of them is minus 3 by 4, find the other. Solution. Let the other number be x. Then minus 3 by 4 multiplied by x is equal to minus 5 by 8. X is equal to minus 5 by 8 divided by minus 3 by 4, which is equal to minus 5 by 8 multiplied by minus 4 by 3, which is equal to 20 by 24, which is equal to 5 by 6. Hence, the other number is 5 by 6. Properties of division. Some properties of division of rational numbers are different from integers. 1. Closure property. If a by b and c by d be any two rational numbers such that c by d is not equal to 0, then a by b divided by c by d is also a rational number. But in case of integers, it is not necessary that quotient is also an integer. 2. Commutative and associative properties. Just like integers, division of rational numbers is neither commutative nor associative. Thus, if a by b, c by d and e by f be three non-zero rational numbers, then a by b divided by c by d is not equal to c by d divided by a by b, except for a by b is equal to c by d. And in the bracket, a by b divided by c by d divided by e by f is not equal to a by b divided by, in the bracket, c by d divided by e by f. 3. Property of 1 and minus 1. For any rational number a by b, we have a by b divided by 1, which is equal to a by b, and a by b divided by minus 1 is equal to minus a by b. 4. 1. Division by itself. For any rational number a by b which is not equal to 0, we have a by b divided by a by b is equal to 1. 2. Division by its own additive inverse. For any rational number a by b which is not equal to 0, we have a by b divided by minus a by b is equal to minus 1. Rational numbers between two rational numbers. There are countless number of rational numbers between any two rational numbers. Example 1. Find a rational number between 1 by 4 and 1 by 3. Solution. A rational number between 1 by 4 and 1 by 3 is 1 by 2. In the bracket, 1 by 4 plus 1 by 3, which is equal to 1 by 2 in the bracket 3 plus 4 by 12, which is equal to 1 by 2 multiplied by 7 by 12, which is equal to 7 by 24. Example 2. Find three rational numbers between minus 3 and minus 2. Solution. A rational number between minus 3 and minus 2 is 1 by 2 in the bracket minus 3 plus minus 2 is equal to 1 by 2 in the bracket minus 3 minus 2 is equal to minus 5 by 2. A rational number between minus 3 and minus 5 by 2 is equal to 1 by 2 in the bracket minus 3 plus minus 5 by 2, which is equal to 1 by 2 in the bracket minus 3 minus 5 by 2, which is equal to 1 by 2 in the bracket minus 11 by 2, which is equal to minus 11 by 4. A rational number between minus 5 by 2 and minus 2 is equal to 1 by 2 in the bracket minus 5 by 2 plus minus 2, which is equal to 1 by 2 in the bracket minus 5 minus 4 by 2, which is equal to 1 by 2 in the bracket minus 9 by 2, which is equal to minus 9 by 4. Therefore, minus 11 by 4, minus 5 by 2, minus 9 by 4 are three rational numbers between minus 3 and minus 2. Example 3. Find 89 rational numbers between minus 5 by 6 and 4 by 6. Solution. We can write minus 5 by 6 as minus 50 by 60 and 4 by 6 as 40 by 60. We can find 89 rational numbers between minus 50 by 60 and 40 by 60. They are minus 49 by 60, minus 48 by 60, and so on till minus 1 by 60, 0 by 60, 1 by 60, 2 by 60, and so on till 38 by 60, 39 by 60. Therefore, 89 rational numbers between minus 50 by 60 and 40 by 60 are minus 49 by 60, minus 48 by 60, and so on till minus 1 by 60, 0 by 60, 1 by 60, and so on till 39 by 60. Note, answers of such questions may or may not be same. Absolute value of a rational number. We have already learnt about the absolute value of an integer in our previous class. Let us recap this. Take any integer, negative or positive. Just the magnitude of the number regardless of its direction, that is, sign, positive or negative, is called its absolute value. Absolute value of mod 0 is equal to 0, which implies mod x is equal to x if x is equal to 0. Example, absolute value of 5 is equal to mod 5, which is equal to 5, which implies mod x is equal to x when x is greater than 0. Absolute value of minus 5 is equal to mod minus 5, which is equal to minus 5 is equal to 5, which implies mod x is equal to minus of minus x when x is less than 0. The same rules apply to rational numbers also. Thus, absolute value of 1 by 7 is equal to mod 1 by 7, which is equal to 1 by 7. Absolute value of minus 1 by 7 is equal to mod minus 1 by 7, which is equal to minus of minus 1 by 7, which is equal to 1 by 7. Absolute value of minus 2 by minus 5 is equal to mod minus 2 by minus 5, which is equal to 2 by 5. Thus, the absolute value of a rational number is also its magnitude, regardless of its sign. Properties of absolute value. A. There are exactly two rational numbers p and minus p which have same absolute value p. B. 0 is the only rational number whose absolute value is 0. C. No rational number has a negative absolute value. D. If p by s and q by r are two rational numbers, then mod p by s plus q by r is less than or equal to mod p by s plus mod q by r. E. If p by s and q by r are two rational numbers, then mod p by s multiplied by q by r is equal to mod p by s multiplied by mod q by r. Example 1. Find the absolute value of the following rational numbers. A. Minus 5 by 9. B. 2 by 7. C. 0 by 8. Solution. A. P is equal to minus 5 by 9. Mod P is equal to mod minus 5 by 9, which is equal to 5 by 9, which is equal to 5 by 9. B. P is equal to 2 by 7. Mod P is equal to mod 2 by 7, which is equal to 2 by 7. C. P is equal to 0 by 8. Mod P is equal to mod 0 by 8, which is equal to mod 0, which is equal to 0. Example 2. Verify that mod P is equal to mod minus P, where P is equal to minus 3 by 10. Solution. Mod P is equal to mod minus 3 by 10, which is equal to 3 by 10. Mod minus P is equal to mod minus 3 by 10, which is equal to mod 3 by 10, which is equal to 3 by 10. Hence, it is verified that mod minus P is equal to mod P.